Hi, I'm Swati Jain. I'm the UA team lead for Rational Focal Point. This is a demonstration on investment analysis using Rational Focal Point. A careful analysis of investment is the key to successful business or a project. To start any project, the investor can rely on various methods to determine if the investment on the project is worth it. It makes a lot easier if there is some kind of data that helps them in the decision-making process. Data that helps to determine how much of investment is required over a period of time, what would the return on investment be at different phases of the project, what is the payback period, what is the net present value of the project at any given time. The ultimate goal of any investment is for all the stakeholders to benefit from the project and have profits from the investment. The investment analysis component of Rational Focal Point contains analytics that provide information on the likely outcome and value of the potential investment. Using the Rational Focal Point investment analysis component, we can build financial models of the expected cost and benefits of our project over time. In this demonstration, we'll consider the scenario of building a financial model in Rational Focal Point for a car manufacturing project. The management needs to determine the potential input costs, output costs, delivery time, quantity, sales and services revenue for the car manufacturing project. With all this data, they also need to analyze the return on investment, net present value, and find out if the project would be feasible and provide optimal benefits over a period of time. To build a financial model in Rational Focal Point, the first step is to determine the monetary and the non-monetary streams for the project. In this project, we can consider some of these non-monetary and the monetary streams. The monetary stream would include the cost and the benefit streams. The cost streams can include the engineering, manufacturing, services and warranty streams. These are the total cost that's borne by the company for manufacturing and delivering the cars. The benefit stream would include the sales revenue and the services revenue. These would be the total revenue generated due to the sales and post-warranty services rendered by the company. The non-monetary stream would include the number of engineers and the quantity of the cars. After we determine the monetary and the non-monetary streams of the project, the next step is to configure the time grid attributes in Rational Focal Point. In Rational Focal Point, we've already created a module called BioCars for the car manufacturing project. Now, we'll create all the required attributes that are required for the BioCars module. Before we create the time grid attributes for our project, we'll create the project start date and the project end date attributes that are required for the project. So now, we'll create a project start date attribute of type date and save it. Similarly, we created the project end date attribute. Now, we'll create a time grid attribute and name it as project specs. Select the Allow Investment Analysis checkbox. The estimates are uncertain entities. To express the uncertainty of our estimates, we specify the values for likely or nominal estimates with high and low bounds. So now, we'll create 4 time grid sheets that can show high, likely, low and actual estimate values. We specify the time interval as yearly for this project. And the date would be the project start date and the project end date. When we create any attributes in Rational Focal Point, a default alias name is created. The alias of the time grid attribute will be used as a prefix when configuring the output attributes for retrieving the investment analysis results. So we'll specify a meaningful alias name for this time grid attribute and name it as bcar. We'll add all the monetary and the non-monetary streams that we determined for our project. So now we'll add a row for the sales revenue stream and specify that as a benefit stream. For this project, we'll consider USD as the unit. Similarly, we'll add another row for the services revenue stream and select the benefits checkbox. We'll add a quantity stream. Since this is a variable stream and is neither a cost nor the benefit stream, do not select any of those checkboxes, and you can specify a separate unit for this. Add rows for all the cost streams. All the cost streams must have the same units. The benefits can be monetary or the non-monetary, but the monetary benefit streams must have the same unit as that of the cost stream. With this, we have configured the time grid attribute for the cars project. The next step is for us to configure the output attributes to retrieve the financial analysis results. For analyzing the investments of our project, some of the parameters that helps us to determine the investment status during the project lifecycle are return on investment, that is ROI, net present value NPV, payback period, internal rate of return IRR, and so on. To view our financial results for these parameters, we'll add all these output attributes in Rational Focal Point. Check out the suggested attribute types for each of these output attributes and also the alias name. Now, in Rational Focal Point, we'll add an output attribute to view the NPV distribution for the project. Ensure that you prefix the alias name with the same alias name that we specified for the time grid attribute. The suffix part of the alias name must be the same as the one that's supported by Rational Focal Point for this type of output attribute. Similarly, we have added all the required output attributes that are required for this project. After configuring the time grid attribute and the output attributes for our project, now we can build the financial model for each of the stream. After configuring the attributes for the module, we'll create a project element. We'll name it as bcar1 and set the project start date and the end date. Click on any of the stream to open the investment analysis mode. By default, the project end date is considered as the delivery date, but for this project we'll change the delivery date. Now let us project the estimates for the engineering cost stream. For this, we need to determine the number of engineers that are required over a period of time. Since we haven't yet created a number of engineers variable stream while configuring the module, we have an option to create a local stream for this element within the IA mode. From the menu, select Add Stream, provide a name and the unit for the local stream. To project the number of engineers that are required for a project over a period of time, we can either specify the values graphically or by using the spreadsheet. Since our projections would be within 100, we'll set the highest Y value to 100. To enter data graphically, just click on the graph and plot the curve. You'll have to plot the curve to indicate all the three bounds, that is high, likely, and low estimates. Other alternative option to specify the exact values would be to enter the values in the spreadsheet. Notice that the plots in the graphs are updated parallelly. To calculate the total engineering cost, we also need other variables such as cost per engineer. We can specify these variables that are required for the stream in the Variables tab. We'll add a cost per engineer variable and set the variable type as normal. The normal variable type lets us set a mean value and the standard deviation. Let us project the total engineering cost for the project over a period of time. To do that, Let's select the engineering cost stream. To calculate the total engineering cost for the project over a period of time, we need to define a formula that is based on the number of engineers over a period of time and cost per engineer. To define the formula for this and also see the result in the time grid, we'll use the calculator tape. Provide a name for the calculator tape and specify the formula. Now run the simulation. To view the data in the graph, apply the simulation in the time grid by moving the slider for each year. Similarly, project the estimates for other cost and benefit streams. Ensure that you save the calculator tape for each of the streams. After projecting the estimates for each of the streams in the project, we can now view the financial results and analyze it. The NPV probability tab contains a probability distribution computed continuously of the net present value. The probability distribution shows the 10th percentile, mode, and 90th percentile values for the NPV. The vertical line in the middle of the curve indicates the mode value. Save the investment analysis data and close the IA mode. The results can be viewed in various chart and table format. For our car project, we are seeing positive and encouraging results. The results indicate good return on investment and the payback period of 5 years.